Okay, so this is the video for lesson A-2. So this is on page 6 of the packet. And, excuse me. So we're going to start off, though, on page 7. Page 7 is blank, and we're going to do 3 problems on page 7 to gear up for this problem on page 6. Okay, so you're going to want 3 spaces, okay? And the directions are to sketch a graph that fits the criteria. Okay, so, get ready and have all that set up, and you should write the directions. And then when you have that all set up, I'm going to go through and put the criteria in, and then we're going to go back through and draw the sketch. Okay, so this first one, we're going to be given this criteria. The limit as x approaches 5 from the left of f of x equals 3. All right, that's the first criteria that we're going to draw a sketch for. The second criteria, the limit as x approaches -3 from the right of f of x equals infinity. And then the last one is going to have actually 2 criteria. The limit as x approaches 0 of f of x equals 5, and f of 0 equals 1. Okay. Alrighty, so when you're doing this, guys, I wrote down some steps that could help. Okay, we'll write the steps out, though, after these 3. All right, so this is the first criteria, and I want to draw a graph that matches this. So you're going to do xy axes, x, y. All right. And guys, the first move you want to make is find the wall. Okay, so let's find the wall. 5. It's at 5. 1, 2, 3, 4, 5. All right, so find where the wall is. Use a highlighter to put the wall in there if you want. All right, so I'm going to do that. All right, so I'm putting the wall in right there. And then the limit is equal to the level. So the limit as x approaches 5 from the left of f of x equals 3. So that means that when we're, it looks like we're going to hit this wall at 3. So wherever it looks like I'm going to hit the wall, I'm going to put an open circle there to start. Okay? So you do the wall, you do open circles on the wall at the levels you're going to hit. And then you're going to figure out which side of this wall you're going to have a graph on. So as x approaches 5 from the left, so I'm going to be to the left of this wall. So I'll just do like a little slash there to tell myself that that's what the graph is going to look like very close to the wall. And yeah, and that's the only criteria, guys. So then from there, I'm just going to just draw a graph. And it doesn't matter. You could make it look crazy. You could just even do a straight line, although that's not very interesting. So I'd make it have some curve, but there's that. Okay. Now the next one, the limit as x approaches -3 from the right of f of x equals infinity. So we are starting with our axes. And then we find the wall. Okay, so this wall is at -3. Okay. Now, guys, if the limit is equal to infinity and not a number, that means that there is no level. Okay, there's no level at which we're going to hit the wall. We're never going to hit, there's never like a level that it looks like we're going to hit. So very close to this wall, I'm going to have, this wall is going to be an asymptote, actually. If you never hit the wall, it's going to be an asymptote. So since this is an asymptote, I want to draw a dotted line. Okay, and then we should label it. You always want to label asymptotes. All right, so that's x equals -3. Now we are approaching this wall from the right side, okay? So we're to the right of this wall, and it never looks like we're going to hit the wall at any level, and it's going, since this shoots up to infinity, we're going to, close to the asymptote, it's going to be looking like that. All right, so you figure out what the graph looks like very, very close to the wall. All right, so very, very close to the wall, the graph looks like that. And then once you have everything in place, you just kind of just draw a graph in that section. It could look anything. It could look like anything. As long as it has this action, as long as this is supported. Okay. Now number 3, this time we have 2 conditions. So the limit as x approaches 0 of f of x equals 5 and f of 0 equals 1. So guys, if they don't have a plus or minus, that means plus and minus. It means that you're approaching from both sides. So I'm going to start with my axes and the wall. Okay. So x is approaching 0. That means that the y-axis is the wall. So here's the wall. Right there. And now I'm going to put an open circle at the level where it looks like, where the limit tells me it looks like I'm going to hit the wall. So 1, 2, 3, 4, 5, 5. All right, so I'll put an open circle right there. And from which side am I approaching this wall? From both sides. If there's not a plus or a minus, it means both. So I'm going to have a graph to the left and a graph to the right. Okay. So I'll expand on that a little bit later, but this is what my graph is going to look like very close to the wall. And now this, if they're giving you just a function value, they're telling you about a closed circle. All right, closed circle here. Okay, so f of 0 equals 1. That means for the x value 0, the y value is 1. All right, so now we've got like 2 sections here, and then just fill in the graph. It could look anything. It could look like anything. Okay, now we're going to do a big example. So this is page 6. So sketch a graph using the following information about the limits. Note, there is not one correct graph, but your final answer should resemble mine in some way. Guys, if you'd like to go ahead of me, you absolutely may. All right. So we could follow these steps for the moves. Okay, so number 1, let's put the walls in. Number 2, step 2, we're open circles on the wall at levels, at indicated levels. All right, so 1, 2, and then 3, closed circles at any given function values. And then the 4th step will be connect the graph between walls. All right, so we're starting out with a XY axis. All right, now let me put my walls in. Oh, let's look at the conditions. So here we've got a limit. X is approaching -2 from the right. We're going to hit the wall there. Okay, so here's some limits. This limit is infinity, so I know I'm going to have an asymptote there. These are going to be closed circles. Closed circles. Yeah, and then this one, I'll say VA. That's going to have a vertical asymptote. All right, so let me put the walls in. The walls are what x is approaching, so -2, 4, and 1, because x is approaching those in the limits. Okay, so -2, 1. Okay. Alrighty, so we'll have a wall there, and a wall there. And guys, the walls, you don't even have to draw them in if you want to just like imagine them. Okay, so there are the walls. Now, open circles on the walls at the levels that the limit is telling us the graph looks like it's going to hit. So, all right, so this wall, x is approaching -2. I'm using both of those. So at 2, I'll put an open circle, and at -1. Whoops, darn it. I didn't mean for it to go right around that number. Whoops, all right. Now this wall, there is no level. So the limit as x approaches 1, it's just shooting up to infinity. So for here, instead of open circles, I'm going to have an arrow shooting way, way up. But on which sides of the wall? On which side of the wall? On both sides. So here's this wall. So it's going to be going like that. Okay, very close to that wall. All right, now this wall here, x is approaching 4, f of x is 3. So that's going to be, I'm going to have an open circle at 3. Okay, so I filled those in. And actually, as I was doing that, I could have even started drawing in the graph. All right, so let's look here. So the limit as x approaches -2 from the right. So it looks like I'm going to hit the wall at 2 when the graph looks like that. And then -2 from the left. So that the graph will be going off like that. Okay. So there's that. And guys, in this step, I should probably also include asymptotes, like arrows for asymptotes. Now, step 3, close circles at any given function values. So they're giving us f of -2 is -1, and f of 4 is 1. So -2 is -1. So we're actually filling in this dot, I think. F of -2. Yeah. All right. So we're actually going to fill in that circle to satisfy this criteria. F of -2 is -1. And then f of 4 is +1. So we're going to have a closed circle right there. So sometimes a closed circle will fill in an open, but other times it'll be above or below the open one. Alrighty. Now, the very last step, so we did all of these things, and the very last step is to connect the graph between the walls. Connect the graph between the walls. So let's look at these. Let's look at this as like regions. So we got this first region, and then we got this second region, third, fourth. So you're just going to be looking at one region at a time. You're not going to connect two parts of the graph if they're in separate regions. Okay, so in this first region, the graph is going to be, I know it looks like that close to the wall. So now just extend it through the region and, just do something creative. Okay, now that was the first region. All right, now this second region here, the parts of the graph that I already have set up are this part here and then that part. So you just have to connect them. And you can make it crazy, but I would just connect, simple. All right. All right, so we got those regions done. Now this region here, so some people might be confused. They're like, oh, am I connecting it to the open or the closed circle? Well, it's gonna have to be whatever makes this limit true. So, yeah, so basically you're just gonna be connecting it to the open circle because that's what would make this limit be true. So like that. And then in the very last region, for that limit to be true, I need to be approaching that wall from both sides. So something like that. Okay, guys, now one of these walls is an asymptote. So this wall here that is an asymptote, I'm gonna label it with a dotted line, and then it's x equals 1. Okay, guys, there it is. And we're just gonna do a bunch of this in class.